formula in a few minutes. Before we derive the formula, I want to look at some of the information that we know in this equation. So S of n is what we were looking at earlier. And A was our initial value, which was 200, which we also recognized were the regular payments that were being made. R was the common ratio, and in this case it was 1.005 to the exponent n minus 1 all over 1.005 minus 1. Now if we take a look at what each of these things represent, the 200 represented the regular payments, and the 1.005 actually represented 1 plus I, so this is 1 plus I as well. And what you'll notice is S of n, which would be the sum of the terms in the series, this actually represented the accumulated amount. So this is what we're actually looking at. So the accumulated amount or the future value of our investment. So if I actually replace what each of these variables are represented with based on an annuity problem instead of just a regular series, let's take a look at what our equation would look like. So I'm going to replace S of n with A. So this would be A equals, A in this case, little a represents our initial value, but when we're looking at it in terms of the problem we saw earlier, we also recognize that this value of A was the same as our regular payments. It was 200. So I can replace this little a with R to indicate those are our regular payments. And then I have my common ratio value ended up being the same as 1 plus I. So I'm going to replace the common ratio part with 1 plus I to the exponent n. And then I have minus 1 all over. Again, R represented the same thing as 1 plus I. So I'm going to replace that with 1 plus I. And then subtract 1. And now I'm going to simplify this a little bit. And I get A equals R times 1 plus I to the exponent n minus 1 over, now if I get rid of the brackets here, I get 1 plus I minus 1. So if I ignore the brackets, I get 1 plus I minus 1, and so 1 minus 1 gives me 0, and so all I'm left with is I. And this is a formula for the future value of an annuity. And so R represents my the regular payments that are being made. I represents the interest rate per compounding period, and n represents the number of compounding periods. So the value of R, I, and n are exactly the same as what you saw when we looked at compound interest, but R is the only new thing. Those are the regular payments that are being made, and so this is a formula for the future value of an annuity. Okay, so using the geometric series formula, we determined a formula for the future value of an annuity. So anytime you see a future value of an annuity problem, now you don't have to sit there and go through the same process we just did deriving the formula. You are more than welcome to just use the formula that we have here now. Okay, so just to summarize, here is the future value of an ordinary annuity formula. The only difference between what I wrote above and what's down here is that the location of the brackets. So here the brackets are just around the 1 plus I to exponent n minus 1, so it's only around the terms in the numerator. But in the second one, which you can also use, it's around the entire numerator and denominator. R is just a coefficient. Both of them work. Doesn't matter which one you use. Use the one that you think you would be more comfortable using. Okay? So let's take a look at what each of these variables represent. A is the accumulated amount, so that's the amount that you want in the future. So that's the future value of an annuity part. R is the regular payments that are being made at the regular intervals. I is the interest rate per compounding period. That's exactly the same as what we saw when we looked at compound interest. So you're taking the interest rate per year, dividing it by the number of times interest is compounded in a year. N is the number of compounding periods. So you're looking at how many times interest is compounded in a year and multiplying it by the time in years. So let's say 4 years, 5 years, whatever it is. Note, the one thing you need to remember is that the compounding interval must match the payment interval. So if interest is compounded quarterly, then that means that your payments have to be made quarterly as well. Or if interest is compounded monthly, then that means that your payments must be made monthly as well. So those are the only conditions for your annuity. And in a couple of minutes, we're going to look at some examples that look at the future value of an annuity.